All right, let's talk about a really powerful tool you see on construction sites, the Hubzug, or as many people know it, the Tirfor. Now this thing is an absolute workhorse, but, and this is a big but, if it's misused, it can be incredibly dangerous. So today, we're going to break down exactly how to use it safely by really understanding its power, the risks, and the absolute non-negotiable rules that literally save lives.
So let's just kick things off with a question that gets right to the terrifying heart of the matter. Just picture it. You've got thousands of pounds of force, all being held by a single steel cable. What do you think happens if that cable suddenly lets go? The answer is pretty much the entire reason we're doing this explainer.
Yeah, the source material does not pull any punches. They call it the whiplash effect or snapback. All of that stored potential energy in the cable gets released in a fraction of a second. It doesn't just fall, it turns into a lethal whip, moving faster than your eye can even track.
So that's where we're going to start. We're going to focus on this one single most dangerous outcome. Because, if you don't understand the absolute worst-case scenario, you'll never truly respect the tool.
Look, we're not just talking about a piece of equipment breaking and you having to buy a new one. This is a literal explosion of energy. A snapping cable flies unpredictably through the air, with enough force to cut through anything in its path. And yes, as we've seen, it can absolutely be fatal. Okay, now that we've properly established the number one danger, let's kind of take a step back and really get to know the tool itself. What exactly is a Hubzug? What is it really for? And how in the world does it generate so much force?
At its heart, it's basically a portable winch. But it's not magic. It's just a really brilliant piece of mechanical engineering that lets one person, with one lever, create and control an immense amount of pulling force.
Yeah, you're not going to find this thing in your garage toolbox for weekend projects. This is a specialist tool. You see it in heavy industry, especially steel construction, where you have to move massive, multi-ton components with millimeter precision.
So how does this whole thing work? Well, it's actually a really clever ratchet system. As you pump that lever back and forth, there are two sets of jaws inside that grip and pull the cable inch by inch, giving you incredible control. And reversing the motion lets you release the load just as safely and slowly. It's also got a critical safety feature built in, a little shear pin that's designed to break if you drastically overload it. It's like a fuse, sacrificing itself to prevent a much more catastrophic failure of the rope or the anchor.
Now this slide right here highlights one of the biggest and most dangerous mistakes people make. A Hubzug is for pulling. It's for tensioning things horizontally. It is absolutely not a hoist for lifting things vertically. The physics and the safety factors are completely different, and using it to lift something is just asking for disaster.
All right, so we get the tool and we get the main hazard. Now let's really dig in and break down the specific risks, all the little ways through user error or equipment failure that can lead to that worst-case scenario.
Okay, number one, and it's the most obvious, overloading. Every single tool has its limit. That safe working load, or SWL that's stamped right on the side, that's not a suggestion, it's a hard limit. The second you go past it, you're operating on borrowed time, and you're stressing every single part of that system to its breaking point.
You know that saying, a chain is only as strong as its weakest link? Well, it has never been more true than right here. The Hubzug itself could be in perfect condition, but if the rope is frayed or kinked, that's your weak link. If the anchor point you've tied off to isn't solid, that's your weak link. And if either one of them fails, the whole system fails.
And failure isn't always some big, dramatic event. Sometimes it's subtle. Pulling at an angle, what we call side loading, puts stress on those internal jaws in ways they were never meant to handle. It causes hidden damage. And it's worth saying again, even a rope that looks mostly okay, but has a few broken strands, has a seriously reduced capacity.
And finally, we get to the human element. Rushing the job, releasing a load suddenly instead of carefully, that can cause things to shift or fall. But the absolute number one, single most critical error, the one that turns a mechanical failure into a human tragedy, is allowing anyone, for any reason, to be in the danger zone, that direct line of the tensioned rope.
So check this out. This risk matrix from the source document just lays it all out in black and white. Just look at that severity column. For the big ones, rope breakage, overloading, anchor failure, it's rated very high. So what does that mean? It means even if the chance of it happening is only medium, the outcome is so catastrophic that the overall risk is just plain unacceptable. And that is why these procedures are so critical.
Okay, we've defined all the risks. That's the scary part. I get it. Now for the most important part of this whole explainer,
the clear, actionable steps you have to follow to control those risks and make sure every single operation is a safe one.
Safety doesn't start when you pull the lever. It starts way before that, with the equipment itself. You have to know the SWL. You have to inspect the tool and the rope before every single use. If you see any damage, any kinks, any broken wires, it's out of service, period. And never ever swap out the rope for a different one. Only use the one made for that specific device.
Next up, the setup. Your anchor point can't just be something that looks strong. It needs to be a verified, engineered point that can handle the massive forces involved. Your pole has to be in a straight line to avoid that dangerous side loading. And hey, if the rope has to bend around an edge, you have to use proper padding so it doesn't get frayed or cut. Now, during the actual operation, when that cable is tight, these aren't guidelines. They are absolute, unbreakable rules. Number 1, no one stands in the line of that rope, ever. We call it the snapback zone or the line of fire for a reason. Number 2, nobody stands under the load, and the pull itself has to be slow, smooth, and controlled. And one person, a single trained operator, is in charge. No confusion. We have covered a lot of ground, a lot of detail, so let's just boil it all down to 5 simple, non-negotiable, golden rules. If you're ever on a job site and you're feeling unsure, just come back to these 5 things.
Think of this as your final go/no-go checklist right before you put your hand on that lever. If you can't give a hard yes to every single one of these points, the job does not start. It is that simple. These rules are your shield against every single risk we've just talked about.
Look, after all of this, if your brain is full and you can only walk away remembering one single life-saving principle, I want it to be this.
This is it. This is the big one. This is the rule that saves lives more than any other. And why is that? Because it assumes that failure is always possible. Even with perfect equipment, perfect setup, things can go wrong. By keeping everyone out of that snapback zone, you make sure that if the worst does happen, it's a failure of equipment, not a human tragedy.
So, I'm going to leave you with a question. This isn't just a bunch of information. It's a call to action for you. Now that you know this, how are you going to apply it? How are you going to talk to your team, set up barriers, and take personal responsibility for making sure that danger zone is always clear? Because your safety and the safety of everyone around you really does depend on it.